Hello guys. In the previous lesson, in chapter 6, section 1, we solved all the questions in practice 6D and the sample problem 6D. And we stop it here. Today's lesson, we start from the question 10 in chapter review, because I solved all the questions in the chapter review related with the topic of the Michael Faraday or Faraday's law for the induced EMF. Okay? Question 10 says, a flexible loop. What do you mean by flexible loop? It means that you can change the loop. Okay? The loop is flexible, it's not rigid. Okay? Of conducting wire has a radius. As I mentioned earlier, when the radius is given, you have to convert to the area. Radius is equal to 0.12 meter. Okay, convert to the area. Area is equal to what? Pi r square. 3.14 times 0.12 square. A is equal to what? A is equal to 45 times 10 power negative 3 meter square. What is this? This is the area of this coil. Okay, the radius is given, we convert it to the area, and is perpendicular to the uniform magnetic field. It is that the plane of this coil is perpendicular to the magnetic field, which means that the angle is 0. Okay, with the field strength to uniform magnetic field with a strength of 0.15 Tesla. Magnetic field is 0.15 Tesla. Okay, as in the figure. In this question, the figure is given. Okay, how many fields do we have? Two fields, A and B. If you look the figures between A and B, the magnetic field is fixed. The magnetic field does not change or remain constant. Okay, so what is changes here? Look, in this case, the magnetic field does not change, but the area of the coil is changes. This is A initial or A1. This is A final or A2. Okay, what happened to the area? The area of the first time was not given, but we found, because the radius was given, the area for the first case, A1 is equal to 45 times 10 power negative 3. Okay, what is the magnitude of A in the second case? I don't know, it's given. As in the figure A below or beside, the loop is grasped. The loop is grasped, it means that is stretched or grasped. Okay, what happened to the loop? Its shape changes. Okay, grasped at the opposite edges and stretched until it closes to an area. What is this? This is the second area. The first area was given in radius, we converted to area was 45, but this area, second area, after changing the loop, is equal to 3 times 10 power negative 3 meters square. What happened to the area? The area decrease or increase? As you can see, the area decreases. It means that A2 less than A1 or A final less than A initial. So which means that delta A is negative. So induced EMF should be positive, or induced current also should be positive. Okay, how did you know? How did you know the induced EMF is positive and current is positive? Because the area decreases. Okay, the area decreases, EMF is positive, current is positive. Okay. If it takes 0.2 second time, delta T 0.2 second to close the loop, find the magnitude of the average EMF induced in the loop. What is unknown? Induced EMF is unknown. The final result should be positive or negative? Positive. Why? Because the area in this case decreases. So what is the difference of this question with the other questions? In this question, the area changes. But in the other questions, in the previous question, as we solved it earlier, the magnitude of the magnetic field was changed. Okay? The difference in this question, the area is changed. When the area is changed according to the Faraday's law, induced EMF is equal to what for changing area? Is equal to NB, not A. Be careful, okay? NB cosine theta delta A over delta T, okay? So this equation can be used when area changes, okay? Replace the number, as you know, number of turn is loop. For the loop, we have one turn, okay? 1 times magnetic field was given is equal to 0.15 Tesla, 0.15 cosine 0.1 times A final minus A initial. A final minus A initial, or A2 minus A1. A final, it was given 3 times 10 power negative 3 minus 45 times 10 power negative 3 divided by time was given 0.2. So 3 minus 45 is equal to 42. Negative 42, negative times negative is positive. Positive what by calculator is equal to 3.2 times 10 power negative 2 volt. By calculator, you can get the final result of the induced EMF. And as you can see, the final result of EMF is negative. Why? Because delta A is negative. Negative times negative, A is positive. Okay? So this is question 10. Okay? Question 11 from chapter review. In question 11, as you can see, look, a rectangular coil, what do you mean by rectangular coil? It means that the shape of the coil is rectangular. It's like that, okay? What is this? This is rectangular coil. With the sides that given 0.055 meter width, and its length is 0.085. So in the case when two sides are given of the rectangular coil, how can you find the area? According math basic is equal to length times width. A is equal to what? 0.085 times its width is 0.055. Area, you can find it, okay, is equal to what? 4,675 meter square. Okay, this is the area. The area was not given in this question, but it is side of the coil was given and we converted to the area. It's positioned so that it is cross-section area. The cross-section area or the plane of this loop is perpendicular. It means that angle is 0, okay, to the direction of the magnetic field. If the coil has 75 turns, number of turns, 75 turns, okay, and the total resistance is equal to what? 8.7 ohm, okay, and the field decreases at a rate 3 Tesla per second. What happened to the magnetic field? Magnetic field decreases, okay? When the magnetic field decreases, it means that delta B is negative. Okay, what is this number? 3, look, 3 Tesla per second. Decrease or increase? Decrease. So you have to write the negative sign. What is Tesla? Change in magnetic field. What is second? Time. It means that delta B over delta T is given directly. Okay? What does the negative sign implies or indicates? This negative sign indicates that the magnetic field decreases. But what happened to the magnetic field? Decreases. At which rate? 3 Tesla per second. What do you mean by 3 Tesla per second? It means that this 3 is change magnetic field per unit of time, as I mentioned earlier in the notes of the Michael Faraday. Okay. What is the magnitude of the induced current in this coil? What is unknown? The magnitude of induced current is unknown. How can you find the magnitude of the induced current? So in this question, you have to make a plan to find I is equal to E over R. EMF over R. Do we have induced EMF? No. So then you have to find the EMF. Okay, at first, EMF is equal to what? Negative N A B, sorry. Negative Na cosine theta delta B over delta T. So in this question, we don't have B initial and B final because B initial and delta B was given directly. Okay, delta B was given directly. Okay, replace to find EMF. Number of turn was given 75 times the area. We didn't have area, but we found it 0.004675. Okay, times cosine 0.1 times delta B over delta T was given directly. Okay, was given directly. It was negative 3. Okay, by negative times negative is positive. Why EMF is positive? Because the magnetic field decreases. Okay, because the magnetic field decreases. Okay, and EMF is equal to what? Is equal to 1.05 volt. So in the question, what is unknown? The magnitude of the current. Replace after finding EMF 1.05, this, okay, divided by radius was given 8.7. The magnitude of the induced current is equal to what? 0.12 ampere. 0.12 ampere. So this is question 11. Okay. Question 12. Uh, 52 turn, number of turn. 52 turns. Coil with the area is equal to 5.5 times 10 power negative 3 meters square. Is dropped from a position where B initial or B1 is 0 Tesla, B final is 0.55 Tesla. What happened to the magnetic field? Magnetic field is changed. But this change of the magnetic field, it goes to increase or decrease. This change is increasing of magnetic field. When the magnetic field increase, delta B positive, EMF negative, current negative. Okay. If the displacement occurs in 0.25 second, delta T 0.25 second. Okay. And the area of the coil is perpendicular to the magnetic field. It means that theta is 0. Okay, what is the resulting average EMF induced in the coil? What is unknown in this question? Average EMF. EMF is unknown. Just replace. Okay, there is no trig in this question. EMF is equal to negative NA cosine theta delta B over delta T is equal to negative number of turn 52. Area was given 5.5 times 10 power negative 3 cosine 0.1. B final 0.55 minus 0 divided by 0.25. EMF is equal to negative 0.63 volts. Why the EMF results is negative? Because magnetic field increases from 0 to 0.55 Tesla. Okay. Question 46. So this is question 12. We solve it. Now we will solve question 46. In a question 46, a student attempts to make a simple generator. Okay, bypassing a single loop of wire. A single loop of wire. It means that number of turn is equal to 1. N is 1. Between the poles of the horseshoe, a magnet with 2 point. The magnet is like that. Okay, so we have. Okay, this is a coil, number of turn is 1 turn. Okay, this is the magnetic field like a horseshoe. Okay, this is the shape of the horseshoe. Okay, with 2.5 times 10 power negative 2 Tesla. B, 2.5 times 10 power negative 2 Tesla. The area of the loop is 7.54 A times 10 power negative 3 meters square and is moved perpendicular to the magnetic field lines. In what time interval would the student have to move the loop out of the magnet field? In what time? It is that delta T is 0. Move the loop out of the magnetic field. What do you mean by move the loop out of the magnetic field? It means that B final or B2 is 0. So this is B initial. So what happened to the magnetic field? Decrease or increase? Decrease. So which means that delta B negative. EMF is positive. EMF should be what? Positive. In order to induce the EMF, in this question, EMF is given is equal to what? 1.5 volt. This EMF is positive or negative? Positive. Why? Because magnetic field decreases. Is this practical generator? So we have to find the time. Okay. Sorry, this is not 0. Time is unknown. In what time? In what time? In what time interval? So we have to find the time. Okay. At first, write down the equation of the Michael Faraday. The equation E is equal to negative N A cosine theta delta B over delta T. So you have to rearrange the equation. Okay. The number of turn area and cosine theta with delta B is located at the numerator. Only the delta T is denominator. Cross multiplication. It becomes like that. Na cosine theta delta B over what? Delta T. Here we have one cross product. 1 times denominator is negative Na cosine theta delta B is equal to EMF times delta T. What is unknown? Delta T is unknown. Okay. To find delta T, the EMF, it goes to the denominator, negative Na cosine theta B final minus B initial. Okay. So you can replace here. Number of turn 1, negative 1 times area was given 7.54 times 10 power negative 3 times cosine 0 1 times B final 0. Why? Because the coil is moved out. The loop is out. Minus 2.5 times 10 power negative 2 over 1.5. So here 0 minus 2.5 is equal to negative 2.5 times 10 power negative 2. Negative times negative is positive. Positive divided by positive time it should be positive. The delta t is equal to what? But time it can never be negative. Okay? And delta t is equal to what? 1.3 times 10 power negative 4. So we have to move out this coil into this magnetic field in order to achieve this induced EMF with a time of 1.3 times 10 power negative 4 or 0.1 13 seconds. So this, because this time is too short, that is why this generator is not practical generator. Why? Because delta t is very, very small. Okay. The last question. The last question, question 47. A coil of 325 turn. Number of turn. This question is very good question. Be careful, please. Pay attention. Number of turn. Sorry. I have a problem with the smart word. Okay, number of turn is equal to 325 turn, and the area is equal to 19.5 times 10 power negative 4 meters square is removed. What do you mean by removed? It means that B final 0. B final is equal to what? 0. Okay. B final 0 because the coil is removed from uniform magnetic field at other angle. The theta is 45 degree. Okay. In 1.25 second time 1.25 second. If the induced EMF is 15 millivolt, what is this? This is the induced EMF is 15 millivolt. You have to convert to volt is equal to 15 times 10 power negative 3 volt. Convert millivolt to volt, you have to multiply by 10 power negative 3, okay? What is the magnetic field strength? It means that B initial is unknown. Okay, what is the magnitude of what? Initial, or what is the magnetic field or magnitude of the magnetic field strength? So in this case, you can find delta B at first, after that replace into the equation delta B is equal to B final minus initial, and also you can write down the equation at first. E is equal to what? Negative NA cosine theta B final minus B initial over what? Over delta T. So as you know, the B final is 0 here. Okay. It becomes negative 325 area 19.5 times 10 power negative 4 cosine 45. The angle is not 0 here, it's 45 times B final 0. What is remain? Negative B initial over what? Over delta. Okay. So the negative with negative cancel. Okay. Negative with negative cancel. And also the magnitude of the EMF is given. Sorry, we have to replace. EMF was given is equal to 15 times 10 power negative 3. Okay. By rearranging the equation becomes like that. BI is equal to what? What is with BI? 325. The negative with negative cancel. Time is 19.5 times 10 power negative 4. Cosine to look the cosine 45. Sorry. Okay, and time the cosine 45. In the upper, what we have the time. Okay, the EMF and time. EMF 15 times 10 power negative 3. So you can rearrange this equation by cross multiply. EMF times delta T, it goes to the numerator. This is EMF times delta T was given 1.25. By calculator, you can calculate the B initial. The initial is equal to 4.2 times 10 power negative 2 Tesla. And B final is 0. So in that case, the magnetic field decreases. Why? Because from this number to 0. Why? Because the EMF is positive. The EMF is positive because the magnetic field is decreasing. And also we have this question you can solve by yourself. Okay? Inshallah, in the next lesson, we will explain the self-induction and the eddy current, and we will finish this section, inshallah. I hope you enjoyed the lesson and hope you get the benefits from this lesson. Okay, so please try to solve all the questions that I solved here. Okay.